The F-22 Raptor, long recognized as the most dominant air superiority fighter in the world, is entering a new era in its operational life. Once designed for traditional dogfighting and stealth penetration missions, the Raptor is now being transformed into a cutting-edge command and control platform that will direct highly autonomous drones known as Collaborative Combat Aircraft (CCA). This transformation is being carried out under a new U.S. Air Force initiative aimed at enabling manned-unmanned teaming. The objective is to allow F-22 pilots to control multiple drone aircraft during combat missions, extending the reach, survivability, and firepower of a relatively small fighter force without requiring additional human pilots. At the heart of this initiative is the integration of tablet-based control systems into the cockpit of every combat-coded F-22. These tablets will allow pilots to interact with their drone wingmen in real time. The pilot will be able to assign tasks, such as reconnaissance, jamming, decoy operations, or even target engagement. The drones, in turn, will operate with a high degree of autonomy, meaning the pilot issues broad mission directives while the drone's onboard systems handle navigation, threat response, and basic tactics. This system is being introduced across the 143 combat-coded F-22 Raptors currently in service. These are aircraft already assigned to operational squadrons. The rest of the approximately 185 total Raptors in the fleet are used for training, testing, or maintenance float. The Air Force is budgeting $15 million in fiscal year 2026 for these upgrades, including $12.2 million for 142 tablet kits, each costing roughly $86,000. This kit includes not just the tablet, but also cabling, integration materials, software updates, testing, certification, and support equipment. Communication between the F-22 and its drones will most likely use the Inter-Flight Data Link (IFDL), a stealth-compatible, highly secure, and jam-resistant data sharing protocol unique to the Raptor. IFDL already allows F-22s to share situational awareness with one another without broadcasting to outside systems. Extending this capability to include drones allows for secure, coordinated group tactics without compromising the low observability of the F-22 or its wingmen. The Air Force is currently developing two drone prototypes under the CCA program, the YFQ-42A by General Atomics and the YFQ-44A by Anduril. These aircraft are designed to be fast, stealthy, and modular. Unlike earlier drones focused mainly on surveillance, these are being built as true combat assets, capable of flying in formation with F-22s and other fighters, surviving in contested airspace, and carrying out complex missions. The Air Force plans to acquire 100 to 150 of these drones in the first phase, with an ultimate goal of fielding over 1,000 across multiple future increments. The decision to start with the F-22 as the initial airborne controller of CCAs reflects the platform's elite status and the urgent need to modernize its capabilities without developing entirely new aircraft. The Raptor fleet remains small but potent, and by adding drone command capabilities, the Air Force is effectively multiplying its combat power without waiting for the next-generation FX-NGAD platform to fully deploy. To prepare for this transition, Lockheed Martin, prime contractor for the F-22, has already conducted flight demonstrations using surrogate aircraft. In one example, a modified training jet was used to issue real-time commands to drones using a tablet interface nearly identical to what is now being adopted for the F-22. These tests validated that a single pilot could manage high-level drone control, especially when aided by advanced autonomy onboard. The unmanned systems, however, workload concerns remain a focus. Pilots flying high-performance, single-seat jets already manage an intense set of tasks involving navigation, threat detection, weapons employment, and communication. Adding drone control into that mix introduces new complexity. The Air Force and its industry partners are aware of this and are pursuing solutions. Over time, it's expected that drones will operate with increasing levels of artificial intelligence, reducing the number of commands needed from the pilot. Eventually, a pilot may be able to simply issue objectives, such as protect this sector or engage that target, and the drones will execute independently within that framework. Testing and experimentation are central to this transition. The Air Force has established an Experimental Operations Unit (EOU) dedicated to CCA development. Initially a small detachment, this unit has now grown to squadron size and is responsible for refining tactics, evaluating systems, and helping define the operational framework for how drones will integrate with the F-22 and other aircraft. Supporting this is Project Venom, a program that uses specially modified F-16s to test autonomous behaviors and swarm tactics in flight. In tandem with these developments, the F-22 itself is undergoing a broader upgrade initiative to remain viable through the 2030s and beyond. These upgrades include sensor improvements, electronic warfare enhancements, and software changes that will allow the jet to adapt to evolving threats. The drone control upgrade is part of this broader modernization package and is considered critical for the F-22's continued relevance in an increasingly contested air environment. The integration of drone command capabilities into the F-22 Raptor reflects the United States Air Force's drive to maintain absolute air dominance. It leverages existing assets in smarter ways, prepares the force for high-end warfare involving distributed teams of manned and unmanned aircraft, and ensures that the F-22, despite its age, remains at the forefront of global air combat capability. This is not a theoretical effort. It is funded, prototyped, and moving into the operational phase. By the end of this decade, the Air Force expects the F-22 to be flying missions alongside autonomous wingmen, marking the most significant evolution in the jet's combat role since it entered service nearly 2 decades ago.